to the next letter going down the alphabet on our list, L, and we're going over the lathe drill. So what is a lathe? Well, in modern technology, okay, this is a lathe, and in here is a motor, okay, which runs on electricity, and it turns this axis around, and it goes in one direction. Okay, usually the direction is down toward you. Okay, you have a shelf, which is a tool rest. Then you have a point on the end. Okay, which in between these 2 points here holds a block of wood. Okay, so let's see. You would take a block of wood that you've cut out, probably on your table saw or something like that, and you place it between these 2 points. Okay, and it's locked in there. Now this is just a sharp point that will stay in a hole, and this side will spin freely. Okay, this side, however, has a few extra kind of hooks in this part, and what does is it grabs onto the wood. So when the motor starts to spin down toward you, it grabs the wood, and this is what actually does the spinning toward you. So what is the purpose of this machine? Well, what you're doing basically is, if I could find my tools. So what you're doing is you have a set of lathe tools, and they're usually a bit of a long handle with some kind of steel sharpened end, and depending on the shape of the tip is the type of cutting that you're trying to do. Okay, so and what you're doing is basically converting something that's square, rectangular, or blocky into something that's round. Okay, so as this spins down and toward you, your tool will lay on this tool rest, and you touch the tool to the wood as it spins down toward you, and you're basically taking off wood until it becomes cylindrical. And you can make all kinds of cylindrical shapes too. Classic things are baseball bats and chair legs, table legs, things of that nature. So I've been mainly using it for spindle making, as well as reloading spindle making, which comes in very handy. So anything that's round and needs to have a straight axis, I mean, this is your machine. So, but this basically comes from the idea of the primitive lathe. Now, the primitive lathe works with a foot pedal called a treadle, and the foot pedal is connected to a cord which goes to some kind of table-like affair, much like this lathe. Okay, the cord then wraps around the piece that you're going to be working between these 2 points. Okay, and it's near a tool rest. The rest of the cord then goes up and attaches to a spring pole. Okay, so as you step on the spring pole, step on the treadle, it makes the spring pole come down, and it goes down together. Okay, now the cord, naturally wrapped around the piece that you're working, is going to turn. However, it's going to turn back and forth, not just in one direction. So the idea really is that when you step down, the piece is actually going to turn down toward you for cutting. then it's going to go back the other way, and then you step on it again down, and it turns back toward you for cutting. So you basically have to touch your tool to the wood as it's on its going down for the downward cut. Okay? And that's the idea of the primitive lathe, which we're going to show you and go over. But right now, I'm going to show you a quick example of taking down a piece of wood from a block to a cylinder very quickly through time-lapse video, just to give you a quick idea of how this is done. All right? And then, how does all this relate to friction fire making? Well, that's the question, isn't it? So, after you see the lathe and the primitive lathe, I'm going to show you the Lathe Drill, okay, for friction fire making. All right, here we go. All right, so since this is not really a lesson in using a lathe, I'm not going to go over specific details and things like that. There's videos, books, all kinds of things if you want to do lathe turning, wood turning, which is a really fun hobby. So, but basically, the points are, okay, you block out a wood so that when it turns on a cylindrically, it's fairly weight even, okay? This way the piece doesn't just go off and flying from the revolutions per second, okay? I put a point in each end, as well as the end that's going to grab the wood. I cut a cross in there, and what that cross grooves do is it catches the wood for the points that sticks out of the motor side. Okay, lock in between the 2 points. Okay, the machine is plugged in. It should be at the appropriate speed that you're going to be working at. Okay? And there's a couple rules about wood turning. One is your tools need to be sharp. Another is your tool must never leave the rest, the tool rest. You must use the appropriate speeds. Okay? There's many things involved in the safety of using a lathe. So you have to kind of be, it's nice if you're mentored by someone who knows what they're doing. Okay? So here's an example of some of the tools that I usually use. I usually only need to rough out a cylinder. Okay? So I have a large gouge, a medium gouge, and a small gouge. Okay, and then I have like a half moon kind of affair to kind of scrape it down. I'm not up on the exact names of all the things about wood turning or lathing, but I get by. So you have to turn your piece down and toward you, and you have to get your tool rest as close to it as you can where it's spinning, okay, and then lock that tool rest in. In fact, I'm going to move it over a little bit, get it in place. Okay, now we're going to lock that in. And here's what I'm going to do. I'm just going to rough this out into a cylinder, and what you're basically going to be watching is a time lapse of me doing this very quickly, taking this squarish block of wood down to a cylinder. Okay, ready? Here we go. Alright, so I've roughed out this piece. By the way, the wood is mulberry. So we unlock our far end from between the 2 points, and as you can see, this is the original squarish portion of the block, and this is the other side with the cross, which was turned by the engine, the motor. And the points in between are now cylindrically round with the wood that has been removed by the tools on the downward stroke. So one of the important measuring devices, which I forgot to mention early in means and resources, is calipers. Because calipers, you can measure the distance in between something like this. So if you need to get your cylinder to a perfect size, then you can measure points in between with a set of calipers. Very, very handy for all kinds of things. Okay. And this is basically how I would do making a quick spindle. I can make a reloading spindle like this. I can make spindle reloads depending on the size. This was a piece of mulberry from part of a down tree that happened in my backyard. Okay, and the wood has been well seasoned. Green wood turned on a lathe is usually much better than dry wood. I think green wood is usually preferable. So, but this mulberry seemed to come out okay. The next thing I would do with something like this is I would actually leave it on the machine, and I would take sandpaper, and as it turns, the sandpaper would smooth this down. So one of the well-known hobbies of today is pen turning, where men will get, or people I should say, not just men, will get wood blanks that are about this, a little larger than the size of a pen, and on a smaller lathe, because this is a larger lathe, they would turn small cylinders into pens from pen kits, and use all kinds of woods, and now they're using all kinds of artificial materials as well, with all kinds of designs. So that is the modern lathe. So our next example is going to be the primitive lathe, of where the idea of the modern lathe comes from. Okay, let me set that up and I'll show you how that works. Alright, so we're looking to get started on showing you the primitive lathe before we go into the lathe drill. Now, while I had the modern lathe out, the machine, I decided to work on a piece of dogwood that I had collected green a couple months ago. So I cut off a section. Let's put that down. And I made myself a new reloading spindle. So here's the oak one that you saw earlier, and this is the new dogwood reloading spindle. And while I was at it, oh, by the way, that's a 3/4 inch hole, instead of the 1/2 inch hole on the bottom of the oak, so this one's a little larger, I decided to go ahead and make a reload of dogwood. And what we're going to do too is use a dogwood base for when we do the lathe drill. So I wanted it to show you, as I get all kinds of mad scientists and make a mess. I make a mess, I clean up. I get all chaotic, I make a mess, get all mad scientist and clean up again. So this is what's going to be on the lathe drill after we finish up with primitive, showing you the primitive lathe. So there's something that I really should clarify, and that's the difference between a spring pole and a lathe, L-A-T-H. Now this is a lathe, L-A-T-H-E, and this is a primitive lathe, L-A-T-H-E, but a lathe, L-A-T-H, is a flat board or a flat piece of wood. So technically this is a lathe, and that's where we think the name lathe came from, is because the first lathes were from a spring pole, which is a round pole, you know, like a sapling bent over, or some kind of branch that's already connected to a tree, and that's what generated the power when you stepped on the treadle. But as a lathe moved from outside into a workshop indoors, instead of a spring pole, they used a lathe, which is a flat board, in place of something round like a spring pole. Okay, I'm going to show you both the lathe and the spring pole, as well as other versions of energy transference. But just to clarify the difference between the two, because it is important. Since we're learning about friction fire and all the ways to transfer energy, it's important to clarify the ways that energy gets transferred. Alright, so I'm going to clean this mess up, and we're going to get on the primitive lathe. And the first one we're going to do is with a lathe, and then we're going to do spring pole. And then we're going to get into the lathe drill, and I'm going to show you some of the other forms of energy transference. Okay? Let's go. Okay, so first let's look at the treadle. So we're down here below my He Dojo, my fire dojo. And as you can see, the fulcrum area is on the end. The resistance is going to be on this end, and what I have here is a cord with 2 clips on them. So I'm going to drop one end through the hole in the table that I have. You can see that coming through. And it's going to clip on this loop, which I have ready for that. Okay. Now the rest of this cord goes up through the table and goes to the piece of wood that's going to be lathed on the primitive lathe. Okay. So let's put that up there. So a treadle is a class 3 lever, right? FRE 123. So the fulcrum is on one end, the resistance is on the other end, so the middle is the effort, right? FRE, class 3. So when I'm on that side of the He Dojo, because we're on the opposite side of the dojo, on that side is where I stand, and I put my foot just above the fulcrum on this side. So, and then when I press down with my foot, that makes it a class 3 lever. Alright? So let's wrap the cord around the piece of wood that we're going to lathe. Alright, so here's the cord coming around through the table, the hole in my He Dojo table. Now I'm going to go around to the other side. Give me 2 seconds. So we take our cord, and what we do is we lift up the treadle, or you could leave it down and then roll the piece of wood that you're going to be lathing in adjusting the tension that's necessary, because after this it has to be connected to the lathe, which is above, because we're doing the lathe first. All right. Now what's important is that there's no obstructions between the cord area of where the, I just made that into a knot, where the cord area is. When I talk about space for the 22 variables, this is one of those things about space. So between the effort with the energy transfer device, such as a lathe or a spring pole, or the others which I'm going to go over, like a bow, there should be nothing interfering with that area. And you have to watch where you're going to be standing too as well, so that you're not in your own way. Okay. So what we do is we wrap this around several times. Sometimes this never goes as smoothly as I would like. So let's see. I've wrapped that around several times. Now this is going to go up and above to the lathe, but I'm going to swing this around a few more times. Alright. And now that we've done that, I'm going to adjust the camera and show you how we connect it to the lathe, at least in this instance. Okay? Be right back. Alright, you might have a little bit of trouble seeing what this actually is. So before I showed you the lathe on the other side of the He Dojo, okay? But here I've moved it over. It used to be out that way, okay? It used to be out that way. But now what I've done is I've pulled it in this way, okay? Underneath this part of the He Dojo, okay? Now as you can see, it goes over the third beam, okay? But what's holding it in place actually is the ceiling. Otherwise I would have some kind of bar there holding it down from that end. Okay, so the ceiling is what's trapping it. And the third beam is the fulcrum on it, or one of the fulcrums anyway. So here, this other beam, the middle beam, kind of stops it. It's a resistance in one sense. Or just kind of keeping it in place. But the real resistance is on this end, where the loop is. Okay, can you see that? Where there's tension. All right. So this works like a bow, as in bow and arrow. There's compression on the inside, all right, and it stretches on the other side. Okay. All right. So what we're going to do is take our loop, our clip, okay, and you can see it's looped around our piece there. All right, this is going to go up, and we're going to connect that to our lathe. And the reason why I brought it over this way from the other side is because it's kind of hard to see, but if you follow the string goes to the woodworking piece and then down to the treadle. Now what I want is for the woodworking piece to be between points A and B. Okay? If you you don't want like the lathe over here, and your piece worked over here, and then going back to the treadle over here, well, what that does is these other angles are creating a lot of force, a lot of pressure that could, if this thing ever gave way between the 2 points, that thing is going to go flying, if you can see what I mean. So by keeping the woodworking piece between points A and B of the lathe or the spring pole or whatever energy transference device you have and the treadle, okay, so it should be almost in a line, almost an exact line. So lathe up here, or energy transference, okay, to the woodworking piece, to the treadle. A, B, C. Should just be as straight a line as you could possibly get that. All right? So I'm going to step on the treadle a little bit here. You can see. And as I do that, you can see the piece spinning. And you can see the lathe doing its job. Okay? And this is how a primitive lathe works. Now, here's what we need. We need a tool rest, right? Okay, so what we need now is a tool rest. Now, this piece of wood is temporarily going to represent a tool rest. Okay? I'm going to flip the light on so you can see a little better. And I'm going to, just as an example, use a tool that's a parting tool. It gouges, it cuts into the wood to kind of separate it. So let's close up in on where I'm going to be. Actually, that seems a bit high. I'm going to use this parting tool instead. Just because, now this is really just for show. I'm not really doing much with this at all. So let's move in on that. Okay. As you can see, there's nothing worked here. I'm going to show you. Okay. Now both ends are secure. Okay. Let me take the camera off here actually. What we're using today is a rattan as my example. This is a piece of rattan. And what these screws are actually bolts. They're bolts that were screwed in through the wood, and then the ends are cut off and sharpened into 2 points. These 2 points, 2 holes are placed in the piece that you're working, such as this piece of walnut, which I just cut on the table saw. Okay, so you get what's as close to center as you possibly can. Measure that out, and then drill 2 holes, not too deep, just enough to hold the piece in place. Okay, and as you can see, it is balanced. Okay, any piece where the weight is off could be dangerous because it could go flying. Okay, but just our example today is this rattan. All right. And I have to say that's a pretty smooth action. So let me put this back on the stand. Let me adjust our camera again. Let's get it back to where we're going to work. Okay, so what I'm going to do is take this parting tool and I'm going to put it to the wood. Careful not to move my wrist. And you're going to see it start gouging. What I have to do is when I push down on the treadle, that's when I have to put the tool to the wood. Okay, and then I have to back up as it comes back. And then as it goes down, put the tool there. Okay, so that's what we're going to do. All right, so here we go. tool goes into the wood, just like that. Let's use a half moon scraper. Let's try that. Let's do that on this side. It takes a bit of practice, but you back up the tool on the upward stroke and you push the tool forward on the downward stroke. Okay? And this is a primitive lathe. Okay? So having shown you this, we're going to go to the lathe drill, and the first thing we'll start with, I think, is the spring pull, because that's the classic. Okay, so I'll show you the setup for the spring pull energy transference. Okay, so we're getting ready to show you some spring pull examples. But what I'm showing you right now is an example of a great lettuce, which is growing next to my sunroom. Okay, I got a couple of them here on my property, and I use the hollow stem when it's dry as, if you can remember back in the day, the Prometheus pipe. Or it's a tube that you fill with coal extender, and you can use it to carry your fire wherever it is you go without a flame. It's just one big large coal and it burns down. It's basically like a giant cigar. So the great lettuce is really good for that. These things grow like, well, this one is probably more than 8 feet tall already. So comparatively, I got a couple of them on my property. Here's another plant we're going to try hand drill with at another point, and this is called beggar's lice, or Hackelia virginiana. If you can see the little white flowers. At some point we're going to be doing a hand drill with that, but that's also growing on my property, just as another material. So I'm going to be explaining a couple things about spring poles, but we're going to do a quick trip on my property as to what's growing here. Here's another great lettuce, but here the giant stem actually got cut. So what's happening is we got suckers, or what would be nascent growths coming off this great lettuce. So we got 4 really good straight stems coming off here. They're going to be really great drills. Okay. Here's a really awesome thistle growing by my sunroom. This thing is really huge. That's not just a hand drill. There's really good bow drill spindles in there. There's a really nice lamb's quarter growing here. I definitely have a couple pokeweeds growing here. Here's some nice horseweed growing next to two great lettuces on my property, which are over 8 feet tall. All right. They are awesome. Here's another one that's been cut. Oops, just broke that off. Sorry about that. Here the stem has been cut on this giant lettuce and this great lettuce, and got some more nascent growths coming off that. Now, just for comparison, we're going to go in my shed for a minute, and we're going to get out a great lettuce stalk. Let's back up here. There we go. You can see that. That is a great lettuce stalk. and I'm putting it right next to that these two great lettuces here, and those are going to be even bigger than this one here. Okay, as you can see here, it's a giant hollow tube. It's very light. I wish I could use that as a spring pole, but definitely is way too fragile. So let's talk about spring poles for a second. One of the main rules, at least for the lathe drill, because we're doing the lathe drill, is you want a solid reload. A cicada just flew away from me. You want a solid reload. If you have a hollow reload, chances are it's going to break under the forces of the unilateral forces, just like a bow drill. Okay. With unilateral forces, you want as much of a solid spindle as you could possibly get. Here's some dock that we're going to be doing some hand drills with much later. I have a whole bunch. Hear that thunder? There's a huge storm coming in. Got a whole bunch of thistles growing here. All of these are going to be hand drill spindles once they're cut. Okay. Got a nice pear tree here. What we're going to do is we're going to use an example of a branch for a spring pole with that in a minute. Okay. What's another good thing? For the spring pole, what we definitely want is a good bow wood. And by bow wood, I mean like making a bow and arrow. The woods that you would use for that. Now here in my front yard, I have a whole bunch of horseweed. Got a lot of good horseweed in here. Okay. And we're going to be making some really good hand drills with this. I'm going to harvest them, collect them. They're going to be really, really nice. Here I have some amaranth growing in my driveway, along with a little velvet leaf. But I got a huge velvet leaf right here. And here you can see the, what you call the, I call them Reese's Peanut Butter Cup seed pods. So, makes for a great hand drill, a lot of good cordage. Okay, so you want a really good bow wood. And what that means is if you took a stick of a certain kind of wood, okay, and you try to break it, well, it's going to fray and hold together. All right, and what I'm going to do is kind of show you an example of that. So let's go inside here, back inside my shop. Let's put this on the stand. Let me get some bamboo. Right. Here's some bamboo. This would make a really good, awesome spring pole, okay? Now, what I mean by bow wood, I mean if you take this and you try to break it, see how it frays and tries to stay together? Compared to if I could find something here, here's a piece of sodal, okay, that's been used, as you can see, for a fire plow. And see what this will do is this will snap in half cleanly. The fibers don't try to hold together. Okay, and that's really what we want to avoid. What you want is like some bamboo. Oh, actually, is this bamboo? Yes, it's bamboo. Thought it might have been rattan. Rattan is going to be another one that you're really going to want. So if you try to like break this, snap this, it's going to really hold together. Let me get another example. Here I have one of those garden stake sections of bamboo where you can really hear that thunder. So if we try to break this, right, see how it frays? It wants to hold, see that? It wants to hold together. Those make the best bowwoods. So those are the kind of selections that you really want for your spring pole. Something that's very fibrous and wants to stay together. Okay. Another important thing is your notch direction. Your notch direction for your lathe drill is, since it's going to be drilling horizontal, okay, your notch could be north, south, east, or west, and it really doesn't matter as long as it is well contained. The south notch is a little tricky because what it needs to be is completely filled to the top already with coal extender, okay? Because it needs to like catch, like as if in fire saw, we have to put a piece of tinder bundle underneath like the bamboo to catch that coal that's being collected all the way at the top, because you don't want everything to just fall down. You can hear it starting to rain. So north, east, and west, as long as it's contained, like we've seen before, like with the incantation drill, it's just got to hold all that dust in there. The south, on the other hand, too, not only needs to be somewhat contained, it needs to have a huge collection of dust on the bottom that goes all the way into the notch to support and collect the coal that's going to come out. Okay, and again, and all of them, of course, need to be stable. Stabilized. All right. Now what else? Now you saw the lathe. Just pulled it off the ceiling there. This is the lathe we used for not just the lathe drill, but also for Jake's drill, which you saw earlier. Now, the idea of Jake's drill actually came from using the lathe from the lathe drill. So there was inspiration from there. What I didn't mention for Jake's drill was another part of that inspiration, that giant toggle that Jake was holding on to. Okay, the giant toggle. Well, a lifetime ago, I used to be a lifeguard, and I worked in a health club, and they had one of these rowing machines that was electronic, and it was a lot of fun to do back when I was younger. But I remember that it was, you know, it's kind of very easy motion to do, and I thought for my son Jake, who was 8 years old at the time, it's a single-minded thing for him to do. He can hold on with both hands. It's a so, you know, it's a gross motor skill. So obviously it was something that he could pull off, and that other kids can clearly and plainly pull off. But Jake's drill, Alexa's drill, all are inspirations that came from the lathe drill itself, which is what we're working on. So, all right. So, what else? Is that it? Oh, what was my inspiration for the lathe drill in itself? Well, I can tell you the exact moment. I can tell the exact moment when I was inspired to do a lathe drill, to create a friction fire device from a primitive lathe. And I can't tell you the exact date and time, but the exact moment was, I was younger, I was in my 20s, And I was flipping through some TV channels, and this PBS public broadcasting show came on, and it was called The Woodwright's Shop with Roy Underhill. And never saw it before. You know, I didn't know who he was. I didn't know what this show was. But, you know, this guy was doing some woodworking, and so I held on to the channel for a little while. And he was putting together something that I had never saw before. And I didn't even know what a lathe was. And here he is making a primitive lathe, and it's called a spring pole lathe. In fact, it's a specific type of spring pole lathe called a German spring pole lathe. And it's, I think, from the 17th century. And so here's what I would like for you to do, because you could research it yourself. Go to www.thewoodwrightshop.com and for Roy Underhill, and there's some photos and some pictures of things of this German spring pole lathe, because he still makes it to this day. In fact, as of the date of me recording this right now, he was running a workshop for a group to make German spring pole lathes, and that class is full. So, and I'm very jealous of all those people, let me tell you, because that looks like a lot of fun. And someday, I'm going to have one of them, because it looks so awesome. And what I'm going to do is one day is actually build that exact, it's something to do for the future, because you always have to have something to aspire to. And I'm going to make one of those German spring pole lathes and create it into a friction fire device. So I'll be doing that someday. But meanwhile, we're going to move on to the variations, some variations, not all, because there's an infinitesimal amount of that we could do. So some main variations that can be done with the spring pole for the lathe, we're going to show you right now. Okay, here we go. Okay, so you just saw me clear the area out here, the sumac saplings, and this area next to my house. So I can't take the lathe drill outside because it's connected to my fire dojo. So what I'm going to do is, since Alexa's drill is based on the lathe drill, we're going to take that outside. Now, as you can see, I made some very important improvements to the design. And so, as you know, my daughter loves Hello Kitty. So I found some Hello Kitty duct tape, and I duct taped the entire, well, almost the entire structure, except for this one beam, which she said to leave alone so that you could see the Hello Kitty stamp. So there's that change. Now, before you saw me do this 1/2 inch steel reloading spindle with the bamboo. Now, before I started using that spindle, I was using this one, this 1 inch, I'm sorry, 3/4 inch copper tube. But what I found was that when my daughter was doing it, it didn't give enough rotation. Obviously, this is a thinner spindle, the steel one, and that gave more rotation. and the copper one had less rotation because of the diameter, so the surface area was larger. Here I have a Atlantic white cedar reload in there, and as you can see, it's the dead space center has been taken out, and it's started to be mated to a reloading base, which is this one here. So I was talking about notches before, north, east, west, and south. So we're going to do an experiment. Okay, here's the notch for the bamboo, but this is the notch for the cedar reloading spindle here. And we're going to do together. If you can recall from the crutch drill, I think I did a double notch. So we're going to do a east and west notch. So this is the vertical version of what we did with the crutch drill. I think we did that horizontally this way, but now we're going to do it vertically. So this is an east and west. And after this we'll do a south notch, so you can see how that works. Now my plan is to take these slivers, and they're going to be bound to the base with wax nylon or artificial sinew in order to contain the coal in the notch. So I'm going to set that up and put the base back in to the structure and get it set up, and we're going to go outside and we're going to work the sumac spring poles. Alright. Also another part regarding the larger diameter spindle, obviously that's going to give more torque. It's going to have much more turning power than the thinner one, and I think for this instance I'm going to want that with these spring poles. So therefore the larger diameter. Plus you get to see something else. Alright, a larger diameter inside Alexa's drill here. Okay, let's take it outside. Okay, so depending upon your sapling's point of view, okay, you can have the sapling on that side, or you can have the sapling behind you, but you just have to be careful where you position yourself, because obviously when you press on this thing, you don't want this thing to hit you in the head. Okay. Now this sapling, this sumac, first of all it's sumac, it's very weak. Okay. Now the other thing is that the only thing that's anchoring this thing down is its roots. And we don't really want to put too much pressure on just the root system. Okay. What we want to do is really support it. So one of the things you can do, and I'm going to show you different ways to do this too, is to stake a midpoint somewhere on the sapling. Okay, so for example, I stake this end in, this pointed end. This end has a fork in it, and the fork is going to rest on the sapling like this. Okay, and you can tie that down, hold it down somehow, one way or another. Okay, and that would support the sapling so that you're not pulling on the root system itself, because eventually the roots are going to come out, and we don't want to do that. So if we go like this, we put pressure on the roots. See how it bends here? But we don't want it to bend there. We want it to bend without pressure on the roots. So we want it to bend that way. Okay? And that will support the structure of the sapling. But this one happens to be rooted in the ground. Okay? So there you go. That's one way to do it. Okay? Let's give this a couple turns so you can see that work. It's working pretty smooth. I don't know if you can see the smoke coming out here. You know what? I'm going to take the camera off. Actually, can you see the whole sapling? Let's try that again. Okay. See how it bends here and not down here? It's not bending the root, it's not pulling out the root system. Okay, so let's turn this right side up. And let's have a look here. Alright, so I'm going to step on the pedal a couple times. And there we go. And I think I'm just going to keep going. Let's see what happens to the notches. Now, in this instance, I'm just going to just keep going as a time duration kind of thing. And see what we get in the notches. Let's see if those slivers hold the fuel inside. We may lose one, we may lose both, but we will have given it a shot. Now, I don't know if you can't really tell what's happening, but I'm starting to lose flexibility in this sumac. See, the pedal stays down. Do we have something? Anything? Let's see. You know, I don't think yet. But you know what? I'm going to leave that dust in there. And I'm going to show you another example of getting more stored energy. Okay? Be right back. Alright, so since I happen to have two saplings, I'm going to kind of show you what I did. And instead of using a brace to hold the center so we don't pull on the root system, is I found another tree or another sapling, right? So, and if you have cord, tie it to the center of that sapling or tie it to the base, and that will keep it from bending at the root system. Okay. Now what I've done too is to add more stored energy, I've tied this sapling to this sapling. See that? So what I'm going to do is put this on the stand so you can see this whole thing work. Just give me a second here. I have to flip the camera on its side so you can see. Right. There's a storm system moving in. It's already thundering, so I have to move quick. Alright. Here's how this would look. So now we have two saplings. So we have double the power. See that? And see how it doesn't bend at the root system? It's being held in place. Especially by the one that holds it at the base. Okay? Now mainly this one here would be like if you're not using the top here. Okay? If this was like a stationary, like a larger tree that won't move. So that's what this is. So, and this is another example. But if you're going to do this, don't do this one. Okay? But this is here to show you the same thing as this. Okay. And there we go. Let's just keep doing a couple rounds. And that's really smoking. All right, show you some more examples.